All right, in this video, I will show how to include a constant in the regression. So this is the code here. This is the file I was working with here. So this is the model we just run. So let's go and add a constant. Basically, to add a constant, you need to make the change to the exogenous variable. So which exogenous variables will work with? Let's work with this one. We'll work with this exogenous variable. Remember this exogenous variable, x var 2, has Henry Hub and LNG. That's a constant. That's x over 2. All right, click run. Now specify the regression. You specify linear model 4 because this is a new regression. We don't want this regression to override any of the previous regressions, so we're giving this a new name. Run. I'm not seeing constant. Let's see. Add x bar 3. Let's see how this looks. Have a constant. All right, so with the constant, they have three variables: constant, Henry Hub, LNG. Oh, this is the problem. We run this on x var 2, not x var 3. So this is a good exercise. We saw here that we run the regression and we didn't get the result we wanted. Why? The result we wanted is an output that shows the effect of our constant, but we didn't get that. Why we didn't get that? Because we specified the wrong exogenous variable. You're supposed to put x var 3. Click run. See, look at constant here. This has happened a lot when you're running regressions in Python and so forth. You're running a model. In your mind, there's a dependent variable and specific independent variables or exogenous variables. So you run that thinking one thing. However, when you write down your code, sometimes you make a mistake, like what we did just now there, and you get an output, and the output is not what you want. And you have to realize that you make a mistake, you have to figure out where you make a mistake and correcting your mistake. And a simple thing like that, you know, we use x variable 2 rather than x variable 3, and we got the wrong result. So this result here. Well, everything is statistically significant. This is significant. This is statistically significant. How we know this? Because we do that statistical test that the beta coefficient is statistically insignificant. So the null hypothesis is the beta coefficient of this 2.28 is statistically insignificant or equal to 0. And we can reject the null hypothesis at the 10% level of significance, the 5% level of significance, and the 1% level of significance. How we know this? This probability here, 0.000, is smaller than 0.1, it is smaller than 0.05, it is smaller than 0.01. So it's smaller than 10%, the 5%, and the 1%. So you're rejecting the null that this coefficient is equal to 0 at all levels of significance. What this means is that this is statistically significant and this has an effect upon the dependent variable. The same principle can apply to this. The same principle can apply to this. We still have the same problem of a perfect array squared. We know previously it was because the Henry Hub was perfectly correlated with the WTI prices. All right, in this example, you plot the oil prices. So let's just plot the graph, oil prices. So the C title, figure plot. So we know before when you plot a graph, we use the figure command. This was the figure command, figure plot. What's the next way how to plot a graph? So what we can see is there's more than one way to do the same thing. So we actually plot a graph here without using the figure command. I'm going to plot the graph like this. All right, so what this is, it has some additional parameters. So we have the title, we have the font weight bold. You could put bold, you could put italic, but I'll leave it as bold, size 24. Let's put it here, leave it as 24, color green. Let's put it as blue. TF plot figure size. Remember figure size. This is the x coordinate and this is the y coordinate. So this is how long it will be. This is how tall it will be. Instead of color going being green, we'll put the color as red. Let's run. You see, because we put the colors blue, color come blue. If you change the font size here to the first size, let's put the font size to 40. This will get bigger. With oil prices will get bigger. See how big the oil prices get. So I'm putting it back to 24. Let's see if we change to italic. Oh, font weight. Frankly, what is italic, boy? Italic is not a weight. Font style. Right, run. See, I change it to italic. Let's look to complete the rest of the code. We're going to plot multiple time series on one graph. Okay, so this plot WTI and Henry Hub. Let's use LNG and returns. Let's just use LNG and WTI. You know LNG is blue You know, WTI is red. So we know the code works. Let's change this to Henry Hub and see how it looks. Slightly different. So we see here, red is WTI, blue is bottom here, is Henry Hub, green is LNG. Can see a very close fit between all, and we know it's for certain. Well, actually, all should supposed to be related because if we realize how we computed Henry Hub, we divide WTI by 6. So this line, the blue line, is parallel to this. And there was a similar transformation that was used and applied to transform the WTI prices to LNG prices. So you see the more or less the same shit, the same pattern, the same high points, low points, low points, because this red line, the oil prices, was used to compute all the rest of prices. And that's why we get almost a perfect fit, because one variable was used to compute and it was transformed to compute the other variables. So this will bring me to the end of this tutorial. In the next video, I can look at a different model, but this is the end right here.